Now that we've talked about when an oxidation number is different from a valence number and when it is the same, we're ready to apply that idea of oxidation numbers to equations. And the way that you typically remember which process does what with electrons is by looking at the phrase oil rig. So the oil in oil rig is oxidation is going to be loss of electrons, and the rig is reduction is going to be gain of electrons. And what's at the heart of this and continues to be the challenge for folks to remember is you've got to keep in mind that electrons are negatively charged. So I think you should take a look at the reduction part first, because that makes more sense, and then oxidation will just be the opposite. Reduction is gain of electrons, and so since electrons are negative, as a substance is converted from a reactant to a product, that element is going to have a more negative oxidation number on the product side. So if you think about the synthesis of water, where hydrogen and oxygen on the reactant side both have an oxidation number of 0, and water on the product side, oxygen gets its typical valence number, oxidation number of -2. So oxygen goes from 0 to -2, that becomes more negative, therefore we say that oxygen in that chemical change is reduced. And if you take a look at the hydrogen on the reactant side as an element is 0, hydrogen in water on the product side is its typical 1A plus 1. Therefore, hydrogen goes from 0 to +1. That's going to be less negative, but do you see in the parentheses, less negative literally means more positive.